If you live in a city like London or Oslo, the average winter temperature is projected to drop by as much as 15 degrees Celsius. There is a common assumption that Europe and North America share roughly the same geographic latitude. If you actually line up the maps horizontally, you find that cities like Denver, Chicago, and New York align directly with Italy. New York is frequently hit by massive winter blizzards, while its latitudinal twin on the Mediterranean enjoys mild, temperate winters. Move further north, and famously frigid Canadian cities like Calgary and Edmonton sit at the exact same latitude as Britain and Germany. Given how far north the European continent sits, it should naturally resemble the frozen Canadian tundra, but instead supports vast agricultural regions and ice-free ports year-round. Europe's current temperate environment is maintained by a continuous influx of heat that actively shields the region from its natural subarctic latitude. The heat keeping Europe warm originates thousands of miles away in the tropical waters of the Gulf of Mexico. This warmth is transported northeast across the Atlantic by the Atlantic Meridional Overturning Circulation, or the AMOC. It functions as a massive oceanic conveyor belt. It operates on a timescale that is difficult to fully grasp. A single molecule of water takes anywhere from hundreds to 1,000 years to complete one full journey along this loop. Without this continuous infusion of tropical surface water, northwestern Europe would immediately revert to the bitter, freezing conditions dictated by its actual latitude. The engine driving this global system is located in the high latitudes of the North Atlantic, near Greenland. As warm surface waters reach the Arctic, they cool and evaporate, leaving behind dense salt. This cold, heavy water plunges to the ocean floor, creating a vacuum. To fill this empty space, the ocean pulls warm tropical waters from the Gulf into the North Atlantic. The precise balance of salt to fresh water in the Arctic acts as the mechanical engine block, keeping this global current moving. As global temperatures increase, the Greenland ice sheet is experiencing an accelerating rate of melt. This is dumping huge volumes of fresh, unsalted water directly into the nearby ocean. This fresh runoff actively dilutes the ocean's salinity levels. The delicate ratio of salt to water that powers the current is being erased. Because the water around Greenland is becoming less salty and relatively warmer, it is losing its density. It is no longer heavy enough to sink. Without that downward plunge to the seafloor, the deep water current grinds to a halt. This creates a dangerous feedback loop. With less water sinking in the Arctic, the current lacks the strength to pull warm, salty water up from the Gulf. The system continuously starves itself of momentum. Oceanographers have bolted a complex network of sensors directly to the North Atlantic seafloor to physically measure the flow of the AMOC. This chart shows the average measured strength of the current since 2004. In less than 20 years, the observed volume of water moving through the Atlantic has dropped from 19 spurdrips down to 15. Just off the coast of Greenland, sea surface temperatures are actually dropping. It is the only part of the world's oceans that has been actively cooling down since the Industrial Revolution. Around 12,000 years ago, melting ice sheets dumped massive amounts of fresh water into the ocean, abruptly shutting down the AMOC in a period known as the Younger Dryas. The physical conditions for that exact event are currently repeating themselves. Recent climate models incorporating real-world salinity data suggest the AMOC could weaken past its tipping point of no recovery before the end of this century. Without the infusion of warm water, northwestern Europe will face severe winter temperature drops that global greenhouse warming is incapable of offsetting. The extent of winter sea ice will expand dramatically, stretching across the North Sea to completely encapsulate Scotland, Iceland, and Scandinavia. Existing infrastructure is entirely unequipped to handle cold extremes of -30 degrees. European nations would need to rapidly build massive icebreaker fleets simply to maintain basic maritime trade. Precipitation levels will drop. Under these new arid, freezing conditions, rain-fed arable agriculture across the UK and Ireland will become virtually impossible. The European continent will endure a permanent climatic shift, forcing millions of people to survive in an environment closer to modern-day Siberia. A shutdown of the Atlantic current forces a massive backlog of heat to accumulate in the southern hemisphere, creating a planetary imbalance of temperature extremes. As this trapped heat collects in the south, temperatures in Antarctica are projected to rise by 6 degrees Celsius, which would accelerate the melting of southern ice sheets and raise global sea levels. The tropical rain belt will shift south, entirely inverting the wet and dry seasons within the Amazon basin. This shifting weather pattern will pull vital moisture away from Africa, intensifying life-threatening droughts across the Sahel region. Because the system takes a millennium to cycle, a collapse triggered this century would lock the next 40 generations of humanity into these altered global conditions.